हेलो फ्रेंड्स, स्वागत है आप सभी का। आज की इस वीडियो में हम बात कर रहे होंगे लैप्स रेट एंड डिस्पर्सन ऑफ फ्यूम, वी कैन से प्लम। सो फ्रेंड्स, प्लम का डिस्पर्सन जब हम लोग देखते हैं तो इसके लिए इम्पॉर्टेंट है कि व्हाट इज़ द कंडीशन ऑफ मेट्रोलॉजी, और वी कैन से दैट कि व्हाट इज़ द कंडीशन ऑफ वेदर राइट एट द टाइम when such kind of operations or phenomena we have to observe. Okay, so now the plum behavior can be studied with the help of various parameter. So let us start. The behavior of the plum emitted from a stack depends on degree of instability or stability of the atmosphere and the prevailing winds turbulence. मतलब ये कि जो बिहेवियर होता है प्लम का, वो कहीं ना कहीं स्टैक का जो डिग्री ऑफ इंस्टेबिलिटी है उस पर डिपेंड करता है, और जो स्टेबिलिटी कि मतलब एटमॉस्फेयर कितना स्टेबल है या इनस्टेबल है उसके ऊपर ये डिपेंड करता है, और साथ ही साथ वहाँ का जो विंड टर्बुलेंस है वो क्या है इस पर डिपेंड करता है। और इस तरह से हम कहीं ना कहीं एम्बियंट लैप्स रेट यानी इन्वायरमेंटल लैप्स रेट और एडियाबेटिक लैप्स रेट को कंपेयर करके हम प्रेडिक्ट कर सकते हैं कि जो स्टैक से निकला हुआ गैस है या कह सकते हैं प्लूम है उसका क्या बिहेवियर होगा। ओके, सो अ कॉमन टाइप ऑफ प्लम बिहेवियर हम कह सकते हैं वो जैसे लूपिंग। सो ये जो होता है सुपर एडियाबेटिक कंडीशन जहाँ पर इन्वायरमेंटल लैप्स रेट ग्रेटर देन होता है इसका, तो डाई एडियाबेटिक लैप्स रेट से। तो इसमें क्या होता है कि लाइट टू मॉडरेट विंड स्पीड होनी चाहिए, और वो हॉट समर आफ्टरनून में ये होता है लूपिंग बिहेवियर। ओके, so under such unstable condition large thermal eddies are formed, and these eddies carry the portion of plum down to the ground, causing high concentration close to the stack before dispersion is complete. So in the area होता क्या पे है, तो वो एरिया जहाँ पर ऐसा कंडीशन जो है लूपिंग प्लम को पॉसिबल बनाता है, ऐसे कंडीशंस अगर हैं तो हायर स्टैक कहीं ना कहीं हमें बनाने पड़ेंगे, ताकि हम प्री मैच्योर कॉन्टेक्ट जो है ग्राउंड से उसको रोक पाएँ और कहीं ना कहीं पोल्यूशन को कंट्रोल कर पाएँ। सो बाय द वे आप ये फिगर देख सकते हैं, दिस फिगर इज मोस्ट इम्पॉर्टेंट फॉर लूपिंग बिहेवियर, जहाँ पर टेम्परेचर हाइट के बीच में आप जो है दिखाया गया है रिलेशन। तो यहाँ पर लैप्स रेट जो है कहीं ना कहीं इन्वायरमेंटल लैप्स रेट इज ग्रेटर देन ट्राइएबेटिक लैप्स रेट, and this is the picture of looping. Okay, so now let's go to another topic. Now this topic is most important, and we can say that when that ambient lapse rate is equal to or very near to dry adiabatic lapse rate, the plum emitted from the stack tend to rise directly into the atmosphere until it reaches of density similar to that of plum itself. This type of emission is called neutral plum. However, this neutral plum tends to cone when wind velocity is greater than 20 miles per hour, and when cloud cover blocks solar radiation by day and terrestrial radiation by night. Please watch the figure. You can see neutral stack emission. So this kind of behavior is called neutral plum behavior. So now the next topic under this unit, we can say when the ambient lapse rate is subadiabatic, means environmental lapse rate is less than diadiabatic lapse rate, the atmosphere is slightly stable. Under such condition there is limited vertical mixing. The type we can say this type of we can plum behavior which obtain in such condition is said to be coning, since it assumes a cone like shape about the plume line, while the dispersion rate is faster for the looping plum. The distance at which coning plum first reaches the ground is greater. Coning is often associated with moderate to high wind speed. Now the next plum behavior, that is the fanning. Okay, so how it happens? First, let me show you the picture, and this is the graph. Temperature and height relation, you can see. So inverted lapse rate is less than triadiabatic lapse rate, and so this picture was about coning, but now right now we are talking about the fanning. Okay, so when the lapse rate is positive in the presence of an inversion and very high wind, the stable lapse rate suppresses suppresses the vertical mixing but not the horizontal mixing. So, if the density of the plume is not significantly different from that of the surrounding atmosphere, the plume travels parallel to the ground in a flat ribbon downwind, and on occasion may be observed 10 to 20 km downwind. This condition is known as fanning. So, for high stack, fanning is considered a favorable meteorological condition because plume does not contribute to ground pollution. So, a fanning plume is often observed at a height and in the early morning in all seasons. So, now you can see the picture for fanning, and this is the graph between temperature and height where triadiabatic lapse rate is very we can say greater than inverted lapse rate. So now, in the area where the radiation inversion are common, construction of stacks high enough to allow discharge of emission above the inversion layer is recommended. So, this solution is not practical for subsidence inversion. They usually extend to much greater heights. Now the next plume behavior phenomena is of lofting. What is lofting? So the preceding three types of plume are observed under condition of uniform lapse rate, but when the lapse rate changes from stable to unstable, plume behaviors are different. For instance, when the lapse rate is super adiabatic, means unstable, above the emission source, and inversion condition exists below the source, the plume is said to be lofting. You can see in picture, this is the profile for lofting. When the pollutants are emitted above the inversion layer, they are dispersed vigorously in the upward direction since the top of inversion layer acts as barrier to the movement of pollutants toward the ground. So lofting is the most favorable plume type as far as ground level concentration are concerned, and is one of the major goals of tall stack operation. Next plume behavior phenomena is the fumigation. So fumigation when inversion layer or stable condition occurs a short distance above the emission source and super adiabatic condition, you can see unstable below the source, the plume is said to be fumigation. The unstable air layer causes the pollutants to mix downwind towards the ground, but fortunately, this condition lasts only for a short period of time, so fumigation is favored by clear skies and light winds and is more common in summer season. Friends, in this profile picture, you can see about fumigation. Now the trapped plume occurs when the fume is caught between two inversion layers, one above the emission source and other below the emission source. The diffusion of contaminants is severely restricted to the unstable layer between the two stable regions. So trapping may be associated with subsidence inversion lasting for several days, where all emissions are trapped below the inversion layer, thus creating worst pollution conditions. The profile pic we can see. So guys, whatever we have discussed so far, uh, these are the summary entire discussion. So you can pause the video and note down the important points for various type of volumes. Okay, plumes. Thanks for watching this video. See you in the next video with another topic. And friends, if you have any kind of suggestion, you can also suggest me. You can comment me in